All right, here is our video for polynomials test review. Some problems I'm going to work, some problems I'm just going to talk about from the key. I'm trying to not make the video too long. So in this first, and so I'm assuming that you've already tried working through the problems and you just need some help on some of them or just need some hints. So if you haven't tried the review at all yet, I would recommend go looking at them first and then come back to the video. So in this first section, we're given some polynomials and we're being asked to identify the direction on the ends, whether they go in opposite directions, whether the right end goes up and whether the right end goes down. And so the places you're going to look at are the degree of your function and you're looking if it's even or odd, and then you're looking at the a value, if it's positive or negative. So an odd degree is the biggest exponent on your function. So an odd degree means the ends are opposite, and the a value, if it's positive or negative. So if the a value is positive, the ends are the right end is going up, and if the a value is negative, the right end is going down. And these two problems right here, 1 and 2, are in standard form. I've made little notes about the degree and the a value and which way that means for their ends. And then I've identified by letter which of these things apply to those problems. The trickier part on 3 and 4 is that they're not already in standard form. And so you might think, well, does that mean I have to expand and multiply out the factors to get it in standard form? And the answer is, that's not wrong, but it's more work than you need to do. To get the degree and the a value, you just need the first term of standard form. So to get it, you just need to multiply the first terms in the factors. So this first term, x, is actually cubed. And then we have this x to the 1. So if you do x cubed times x to the 1, you get 1x to the 4. Now you have your degree and you have your a value. Same thing in this next problem, number 4. This x value is squared. This x value is to the 1. So I have x squared and x to the 1. But we also have a negative out front. That's really just like multiplying by a negative 1. So then multiplying all this out gives me negative x cubed. Now I know my degree and I know my a value is negative 1. In this next section, you're being asked to write a polynomial in intercept and standard form. Intercept is the same as factored form. And so we're given zeros, negative 1. Its factor is x plus 1. It has a multiplicity of 1, which means it's occurring one time, that factor. Then we have the 0, 3. Its factored form is x minus 3. It has a multiplicity of 2, which means it occurs twice. So this is my factored form right here. I have an a as a placeholder. The problem is not asking me to solve for a. I just put it there as a good practice. And then so this is the intercept or factored form here. To get it into standard form, you multiply these groups together. So you FOIL the first two, and you get x squared minus 2x minus 3. And then you take that trinomial times this last factor of x minus 3 I showed with box method here. You combine your like terms and you get this answer up here. And this problem said degree 3, which checks out because after we got our standard form, it has a degree of 3. And then a number 6 over here works the same way, only this time I have 4 zeros and 4 factors that have to all be multiplied out and combine like terms. For this next section, we're being asked to state whether these functions are polynomials, and if they are, state the degree. If they are not, explain why not. So you're looking for a few things. You want to be sure that there are no x's in any denominators. If there are, you can automatically say, no, that's not a polynomial. So this one, automatically not. You don't want to have any x's inside a square root or a cube root. And so that is happening here. So that one, no, is not a polynomial. You want your exponents to all be positive whole numbers. This function, we would say, yes, it's a polynomial. You notice that it is a fraction, but there's no x's in the denominator. And the degree is 1 because the exponent here is a 1. And then this last one is a yes, it's a polynomial, and the degree is 6. Now this is not in standard form, so you have to be careful to check every exponent and find the biggest one, and that's the 6 right there. For this next section down here, I'm going to work through one of these. I'm going to work through the second one. You can see the solutions to the first one on the PDFs in your Google Classroom. So we have this graph. This is find the equation, write your answer in intercept form. Remember that means factored form. And remember to determine your A coefficient. So we're going to start by identifying the roots. So this root is -2. That comes from a factored form of x plus 2. And because the graph crosses straight through, we know it has a multiplicity of 1. This root right here is -1. That comes from a factored form of x plus 1. And it's also a straight cross through, so a multiplicity of 1. This root at x equals 3 comes from factored form x minus 3. It has a bounce, so its multiplicity is 2. So we can set up our general form with our A placeholder, x plus 2, x plus 1, and then x minus 3 squared. And then to figure out what the A value is, we're going to use this given point right here. That's at 2, 3. That's an x and y value, and we're going to plug those in wherever we see x and y in our standard form. So I'm going to put 3 for the y and 2 for all the x's. And then you simplify the parentheses. This one is a -1 squared, which is +1. Oh, sorry, this 3 is a negative where the y is. So now I have -3 equals 12a. Divide both sides by 12, simplify, and you get -1/4 equals a. That goes back into my general form. And you don't need to multiply these factors out. It asked just for the factored form. And then also, if you were asked to find how many roots this equation has, or this function has, it has 1, 2, 3 real roots. This is a double root, so I'd actually say this represents 2 roots, and then 3, 4 altogether. The degree you could determine by the turning points, 1, 2, 3, plus 1, so you know the degree is at least 4. Okay, this next section is graphing. We actually didn't end up putting a problem like this on the test, so check the PDF in your Google Classroom for the solutions to that section. They are really good problems for practicing information that is going to be on your test. We just aren't explicitly asking you to graph. So check the PDF key to figure out the behaviors and answers to those. For long division, I'm going to work this one that has the second degree. Check the PDF key to find the work for number 15. So you'll want to put 0 placeholders for missing x terms. So it's the divisor is missing an x, so I have 0x there. The dividend is missing an x cubed, and then x squared, and an x, and well, that's it. So we start by dividing the first term of the dividend by the first term in the divisor. So 16x to the 5th divided by x squared is 16x cubed. Notice how I'm lining that up with the like term, the x cubed that's in the dividend. So then this 16x cubed gets multiplied by every term in this divisor, the whole thing. So it's like a distributive property. So 16x5 plus 0x to the 4 plus 16x cubed. And I'm going to subtract off everything in that row. So that means changing the signs of everything. These cancel. I add here negative 12x to the 4 minus 16x cubed. I bring down the next term, which is 0x squared, and I start all over again. This first term in this row, now divided by this first term in the divisor, gives me negative 12x squared. This term, including the negative, so negative 12x squared, times all three things here, gets written down here. So negative 12x to the 4 minus 0x cubed minus 12x squared. I need to subtract off that whole row, so that means the same as changing all the signs. Cancel. Now I add the things, negative 16x cubed plus 12x squared. Bring down the next term. Start all over again. This first term divided by this first term. So negative 16x. Negative 16x times everything here. Negative 16x cubed minus 0x squared minus 16x. Subtract off that entire row, which means change the signs. These cancel, and I get 12x squared plus 16x. Bring down the last term, do everything one more time. This first term divided by this one is a 12. Positive 12 times all of this. Subtract them all. This cancels, leaving me 16x minus 10. This is my remainder. So I take my answer here plus the remainder over the divisor of x squared plus 1. And that is my answer.